Today, we'll cover an important topic in TIG welding that every welder should know: current and polarity. Choosing the right polarity in TIG welding affects not just the bead's look, but penetration, arc stability, and weld strength. A weld made with the wrong current type will never be high quality, no matter how well you adjust the settings. In this video, what do alternating current and direct current mean? Which polarity is used for which material? How does polarity affect the arc and the heat? What are the consequences of wrong polarity? I will explain it clearly. The most commonly used current type in TIG welding is direct current. In direct current, the electrode is connected to the negative pole, meaning the tungsten electrode is negative and the pod is on the positive pole. In this case, the current flows from the tungsten electrode toward the workpiece. Because of this, most of the heat is concentrated on the pod. The arc becomes narrow and focused. Penetration is deep and controlled. That's why direct current is the ideal choice for carbon steel, stainless steel, titanium, copper, and their alloys. In summary, the advantages of DC electrode negative are a narrow, focused arc, high penetration, minimal wear on the tungsten tip, and a stable, quiet arc. When it comes to welding aluminum and magnesium, direct current is no longer sufficient. This is where alternating current comes into play. In alternating current, the current constantly changes direction. The electrode is sometimes positive, sometimes negative. This change occurs about 50 to 60 times per second. The biggest advantage of alternating current is the oxide cleaning effect. The aluminum oxide layer on the aluminum surface has a very high melting temperature. In direct current, this oxide layer does not break. In alternating current, the oxide breaks in the electrode positive phase and penetration is achieved in the electrode negative phase. These two effects work alternately. In summary, the advantages of alternating current are that it effectively cleans aluminum oxide. It provides a brighter and cleaner bead in aluminum and magnesium welding. It reduces the risk of porosity and contamination. In modern TIG welding machines, the cleaning and penetration ratio can be precisely controlled thanks to AC balance and AC frequency settings. So, how is polarity selected? The rule is actually very clear. Steel and stainless steel, DC electrode negative, aluminum and magnesium, alternating current, titanium and copper, DC electrode negative. What happens if we try to weld aluminum with direct current? The oxide layer doesn't break, the bead becomes dull and dirty. Penetration weakens and weld strength decreases. So the problem is not in the settings, but in the polarity. In summary, polarity is the foundation of TIG welding. Direct current electrode negative, narrow arc and deep penetration, alternating current oxide cleaning, and balanced penetration. This concludes our guide where we explained how choosing the right polarity in TIG welding directly affects arc stability, penetration, and weld bead quality. If you think this video was helpful, don't forget to like it and subscribe to the channel for more TIG welding training. See you in the next video.